Hi everybody, this is the circle unit, lesson 11, and today we're going to talk about radians and unknown length and area problems. So if you're interested in finding out more about radians, there is a website I have here. It's called Purple Math. Radians is another way of measuring angles. So up until this point, we've only measured angles in degrees. But this would be like only measuring distance in inches or weight in pounds. There are other ways of measuring angles. We'll be examining measuring angles in radians today. Radians are based on a simple fact that all circles are similar. So the definition of a radian is the measure of a central angle. So this right here is a central angle, okay, where the arc it subtends is equal in length to the radius. So this radius is r, and the length of this right here, that arc, is also r. That's equivalent to 1 radian. Now, you don't need to really worry about that. Radians are on the reference sheet, so they'll always be given to you, the conversion. And radians is something that we're just touching upon here in geometry, but it will be something that you definitely talk about more next year in math. But it takes 2 pi radii to go all the way around any circle. That's why the circumference of a circle is 2 pi r. Therefore, 2 pi radians is equal to 360 degrees, right? In degrees, to go around a circle is 360 degrees. The circumference is 2 pi r, so it takes 2 pi radians to go all the way around. Here's the conversion right here. So if I want to switch from radians to degrees, 1 radian is equal to 180 over pi degrees. And to go from degrees to radians, 1 degree is pi over 180 radians. Okay, so you can see that they're just flipped around there. Again, it's on the reference sheet, so we don't need to worry too much about it. So if I want to convert 270 degrees to radians, all right, so 270, I multiply it by pi over 180 because I'm converting 2 radians. So I just need to reduce this. Well, the zeros can cancel out, all right, and I really have 27 pi over 18. Now 27 and 18 are both divisible by 9. 27 divided by 9 is 3, and 18 divided by 9 is 2. So the answer is 270 degrees is equal to 3 pi over 2. Let's try one that goes the other way. If I want to convert, so now I have radians, pi over 6, and I want to convert to degrees. So pi over 6, to convert it to degrees, I multiply by 180 over pi. Well, the pi's cancel, and 6 goes into 180 30 times. So my answer is it's 30 degrees. Okay, not too bad so far. Let's look at the next page. So in the next page, I have circle B has a radius of 10. All right, so I'm going to draw circle B. Has a radius of 10. All righty, 10. And the measure of a central angle B is 1.5 radians. All right, so this is 1.5 radians. Find the length of that arc. Well, here's the deal. The length of the arc, this is how we learned it. The length of the arc equals the angle over 360 times 2 pi r. Well, the thing is, I learned this in degrees. This formula is based on degrees. It's not based on radians. All right? So I need to first change to degrees. So I'm going to take my 1.5 and I want to change to degrees because that's in radians. So 1.5 times 180 over pi. So that I'm just going to do in my calculator. 1.5 times 180 over pi. And that gives me 85.94 degrees. Okay, great. Now I got the degrees. I'm going to put it up here. So I have 85.94 over 360 times 2 times pi times 10. Okay, so that is my arc length. So I'm going to do that in my calculator. 85.94 divided by 360 times 2 times pi times 10. And that gives me 15 centimeters. Okay. Next up, what is the measure in radians of the central angle of a circle that intercepts an arc of 1.5 radians if the radius of the circle is 3? Okay. So same thing. I need to be working, what is the measure in radians of the central angle of a circle that intercepts an arc of 1.5 centimeters if the radius of the circle is 3? So let's, again, length of an arc equals the angle over 360 times 2 pi r. Okay? I know the length of the arc. That's 1.5. I don't have the angle, but I do have the radius. Okay? So I'm going to take the length of the arc, and let's get rid of that 360. I think that would be the easiest thing to do. So I'm going to multiply by 360, gone. That means I'm multiplying this side by 360. Well, 360 times 1.5 is 540 equals 6 pi, because 2 times 3 is 6, times x. Now to solve for x, I'm going to divide by 6 pi. Again, when you do that in your calculator, make sure you're putting parentheses around that. So 540 divided by 6 pi, okay, and x equals 0.5. Oh, I'm sorry, x equals, I went too far ahead of me, 28.64. Now that's in degrees. The problem is they want to know the answer in radians. So the formula that I gave you is just working in degrees. So I want to change the 2.864 to degrees. So x equals 28.64 degrees. And I want to change to radians. So 28.64 times pi over 180, because that's my conversion. I can do that right in the calculator. And that's 0.5 radians. Okay. Now, when you get to pre-calc, they're going to show you an easier way. There's going to be another formula that you're going to use when you're working in radians. But for now, I don't want you to have to worry about memorizing another formula. I'll probably show you in class tomorrow what that is, but this is the way that we do it right now. Okay, and that was it. All right, so we'll practice that all tomorrow.